We're in section 2.3.3. This is the related Sage code. Clearly see they're giving me code here to type in. Hopefully as you're typing things in, you're trying to make sense out of what's being typed, all right? There is a lot of redundancy, though. We do things, over and over again, and that's part of learning, too. You do things over and over again. Now, certainly, if you go to the web and go to the Sage website and you go to their forums, you'll see a variety of other ways of doing things, all right? You can't hurt to look what people are doing and the kind of questions they're asking on in the Sage forums. So, just going back over this, let me just look at the question again. Not the question, but the code. And I notice that they have equations. They look at simultaneous equations involving some variable n and a variable x in it. All right. So let me just go to my Sage. We'll look back over the code look over the notes in a second. But I'm just going to type it in, see what happens. All right. So reset, basically just giving me a clean sheet of paper, so to speak. I'm going to say n and x are variables. I can clearly see that. Var. And then I'm going to say equation 1. So equation 1 is being assigned. That's the equal sign. It's an assignment operator. It's being assigned n star n minus 1 star x squared. And the double equal sign says we have an equation now. That's equal to 840. I'm going to do equation 2 now. And I'm going to say n star n minus 1 star n minus 2. Whoops, made a mistake already, didn't I? So I noticed I looked up, by the way. N minus 2, n minus 3, star x to the 4, double equal sign. I gotta look at that number. Looks like 21840, star 24. Okay, I'm going to solve now, and let's see what happens. Now, square brackets, I'm giving you a list now. Equation 1 and equation 2. I'm going to close the list out, and then I'm going to say solve for n and x. Let's see what happens. All right, so give me a bunch of answers over here. Now, certainly, someone's going to say, I don't know why I did that, and it's almost pointless, really, except that we're trying to learn to code. And certainly looking at that, I know I got a response from this over here, which is basically giving me a solution to this. There's two nonlinear equations involving n and x, and it solved it, and it came up with 1, 2, 3 points, 4 points of intersection. So what I want to do is go back over and see, what question does this pertain to? And I always say that, I hope you realize you've done this by hand already, but you may not recall that. And it happens to me all the time, by the way. I've done something, I just don't recall doing it. All right. So it looks like this question over here, right? So I want to point out we did this by hand. All right. So what do we do? Let me go back to my Sage instance so you see what I'm doing over here. I definitely typed this equation in. And what's that equation over there? N times n minus 1. And again, I'll point out to you, this is the equation we're typing in over here. All right. I also typed in another equation. And again, we've already went through this and talked about how to do it by hand. But I typed this in also, equation number 2. And then we get n minus 1, n minus 2, n minus 3, x4. Yeah, looks like I typed it in okay. Now, someone says, I don't even know what the question was. I want to go back and read it to you. The question is the third and fifth term of expansion, blah, 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 is 420 and blah, 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 respectively. Find all integral values of x and n. So I'm looking at it. This first solution, by the way, these are not integers. That can't be the answer. The second solution I'm getting, this is x and n. These are not integers, but now I'm getting integers now. And what are the integers going to be? 15 minus 2 and 15 and 2. All right, so 15 for n, minus 2 for x, 15 for n, 2 for x. All legitimate values, by the way. So let's take a look what they got for the answer over here and see if they got the same answer. Yeah, they did. They said n is 15, x is plus or minus 2. All right, so the point of this is not to use Sage to do the problem. The point of this is do the problems paper and pencil, but at some point in the future, especially if you're going to applied mathematics, you're going to have to learn how to use a computer algebra system. And Sage is an excellent choice for learning how to use a computer algebra system. It's also going to be transferable to other computer algebra systems. For example, let's say you go to a university that says math lab's the way to go. Well, you know what? Having Sage at your disposal is going to help you. Now, again, I hope you're going to a university where they're not telling you what to use. They're giving you options, though. And I really think that the single best option for you guys is Sage. And the reason it's open source. You can download it. It's got a great community of participants working on it. It's got a lot of books out there written about it that are freely available. And it's professionally used. I think any big university is going to have Sage on their network computers. There's no doubt about it. It's a great system. All right. Thank you for paying attention. And again, I really do appreciate that. Thank you so much.